what are we building? It's a board. Looks like there's a lot of stuff on it, and there it is, but it's going to go quick, and we're going to build it piece by piece, try to explain to you how it works, as well as test as we go. Now, in 44 steps, we'll build this board, and you can see it's organized, kind of like the Geiger counter. We have our memory storage device. We also have our sensors, pressure, temperature, accelerometer, gyroscope, and even a humidity sensor that you breadboard in the little breadboard area that you're going to add. And now that board is schematic and answer the question about how to find and use that schematic. Now the brain of the board itself is the Arduino, which we'll get into in a future lesson. We're not going to be using that at the moment, but the shield utilizes the Arduino. It plugs into that Arduino to make it work. And we'll cover this in more detail, but basically the Arduino provides the microprocessing power, all the different programming we're going to do with it, as well as the power regulation for the shield. Now, as we get ready to start handling hardware, as always, we want to be using our ESD strap. So make sure you got that plugged in and nice and there right here. And you'll notice in these boards, there's also some sensors and things already pre-soldered for that same reason. And in many cases, these can only be done with a special machine that pastes the solder on. And you'll see some of that hopefully here in the video. And so you have all these breakout boards. It should be a SD board, there should be a pressure board, pressure and temperature. There should be a gyro board, and then there should be an accelerometer board right here with 2 accelerometers. And then there should be one more board, and this is a live question. The high Z accelerometer in this case looks like it's still in the package and not on the board, which in the real workshop we have you do that reflow soldering. Here's my board right here. And you can see the solder pads are right here. And there's only one way to do that, and that is to use a reflow station, which I don't even have in my current situation. So we'll figure that out when we get to it. Now, those are all of our ingredients. And just before, like we made chocolate chip cookie, we're going to make sugar cookie this time, but those ingredients are going to make this a magical device that we will hopefully understand how that magic works. So this is the shield, and we're getting ready to help you understand how to build that. But again, use your highlighters to go in there and highlight the different aspects as you build it. I want to introduce 2 weird things. So enter Rob. Rob has robbed us of all of our greenness. And Rob has turned our graph into this. So this is our baseline. Everything at this point hasn't been built, hasn't been tested. And when we go back to this picture, that's what we're trying to get to. A fully integrated, fully tested shield system. So this is how we're going to keep track of where we've been and where we're going, and as we've tested that through this. So you'll get ready to see that a lot. So if there aren't any questions, which there probably are, but I can't hear you, so we're going to keep this mount soldering. So I'm going to turn on my soldering iron. And basically, if you look at the picture on the left, those are some really small surface mount resistors and components. And then you look at them zoomed in, you're just like, oh my gosh. And we have found the largest surface mount components we can to make this hopefully a positive learning experience for you. So you can see theirs and you can see ours in terms of relative shape and size. And honestly, the hardest part sometimes of doing these after you've done the first couple is just getting them out of the packaging and not flicking them on the floor, which I'm sure I'm going to do a bunch here today. So this is, again, the way we want you to orient the board. Now, in this case, since it's surface mount, a lot of what you install will be soldered on the very same side that you're installing. All right, so let's get ready to start. I'm going to use these wonderful third hands, helping hands that are kind of wimpy, but I'm going to keep giving them a try because that's what I was able to send you. So there we go. That looks pretty good. And the area that you see on the slide is where we're going to install. Now, unlike the Geiger counter, we're going to install all the same values of resistors at the same time. So we don't drop them and lose them and not know which one is which. So that's one improvement to this build. And we're going to start with R1. So what I want you to do, and we're going to install almost all of the resistors right now. So just find your resistor bag and kind of push everything else off into a pile. And I'm going to pull out R1, which is a 1K ohm resistor. So let's see here. And now it's time to actually start the next step, which was the capacitors. So first thing, just a little bit about capacitors. In this case, we use a lot of capacitors on this board, and they kind of work just as a filtering within the circuit. So think of this picture here that you see with a sink. You've all probably turned on a sink where you've been sprayed with the water. And sometimes you have a sink that's just got a nice clean flow of water and sort of filtered and focused that stream of water. And these capacitors that we're about to solder on just basically do that in the circuit. They keep that signal clean and focused as it goes through the shield. And you can see here on an oscilloscope just sort of the difference between a smooth and a messy signal, and how close that filtering occurs, just like with your water coming out of the faucet. If you had that little screen in the faucet well below where the water's coming out, it really wouldn't work. So we try to put these filtering capacitors really close to where the signals are being generated. And one of those most important signal sort of smoothing features is with these level shifters. And by the way, we've talked about what a level shifter is, or at least that we're using 2 of them, but in this slide here, I want you to think about a level shifter as a translator. So like on Star Trek, I just, I click this little thing and everybody can hear me and I know what language we're speaking. But in electronics, a lot of things talk at 5 volts, 3.3 volts, 1.8 volts. And on our board, we use both 5 volts and 3.3 volts. So level shifter basically translates those signals between 5 volts and 3.3 volts or the other way as well. So that's all we're doing is with these level shifters. And we want to make sure that those signals going in and out of those level shifters, as well as all of our sensors, are conditioned and smoothing of that signal. So very much like we used before with our resistors, we're using surface mount capacitors. Now the only problem with these is they're not labeled, so we definitely don't want to drop them while we're soldering them. So we're going to go and solder like we did before, with all of these being recorded or soldered the same values as we go. So we're going to start with our capacitor bag right here, and I've readjusted my workspace just a little bit to try to make this a little easier for me to solder, and so maybe you can emulate that as well while watching these videos. But that's what's in the slides, so by golly, that's what we're using. So we're talking about capacitors on the shield, and then we went to the next video, and that's where we're at here today. So we're going to continue adding these capacitors now to the little gray boxes you see up top, which are what we call our breakout boards. And I'm not sure where I'm supposed to say this, but I'm going to say it right now, and that is, if you look at this shield here, eventually we're going to start adding what we call breakout boards. And the reason we do this is so that if you ever had to take the sensor off or replace it with potentially a new entirely different sensor, assuming the pinouts are roughly the same or the data lines are the same, you could remove the breakout board and put a new one on. And so you're going to start working with these breakout boards right now, and we'll start adding their filtering capacitors. So go into this bag right here that you see breakout boards, and make sure your ESD strap is on. And I'm going to pull out what's called the gyro board, and I'm going to take a closer look at this. There we go. And looking here, this is my gyro board. And you'll notice there's a whole bunch. I'm going to move my actual shield out of the way, and I'll work with this guy. If you've got some of your old ESD foam, that works pretty well for holding it in place. And we're going to add one of these capacitors, and this is important to pay attention to the locations that we're using. There we go. And I'm going to be doing C1. So again, start with orienting your board, as I just about not did correctly. Add some solder to C1's pad. Bring in my capacitor and set on the
blob, and then hold it down while I remelt that side, and then bring in the other side. I'm going to zoom in just because I have that power. Maybe. Not too shabby. I like it. I'm going to accept it. You can see it's off the board just a little bit. That's okay. It's all right. It's way off the board. Yeah, I would say. I want to fix that. Okay, let's move on to what I hope is step 9. Step 9 is our accelerometer boards. And I'm looking here at this board, trying to orient it with the slides. And you can see I'm going into C6. So only one here. There's a lot more there coming up, but I'm going to go ahead and do C6. And I'm going to pull out some more of these. I'm just going to dump them all out because I know I'm about to use them. Again, lining up and there's no upside down or upside or top side to these. The main thing is to get them with the metal on your little blob. And you see there my workspace did not support that test. So I'm going to go and stick it in this foam and try it again because it tipped on me and it might still tip. And maybe I'll pull out my third hands here in a moment if this doesn't work. I think I got it, but it looks like I didn't do a good job. But it works. It will work. Now be mindful of these sensors while you're soldering. We're not going to be able to help you if something gets on that with solder. So try to make sure you're staying clear of those. There we go. Oh, I didn't let you look at my work, but you can see it's crooked, but it's going to work just fine because I've got a good connection there. All right, let's move on to step 10, and we're going with the pressure board. Now, I'm going to go ahead and point out to some of you, at this moment of recording, some of these little pressure sensors, look how small. I'm going to zoom in for this too. Look how small this little sensor is. It's pressure and temperature. That is a really small sensor. And we pre-soldered these for you, but some of you may not have this board yet because at the time of recording, that sensor is back-ordered to around April 15th, maybe later. So we have to get the sensors in, we have to solder them, and then worst case, if you don't have this board yet, you will be getting it in the mail, and you'll be able to do these steps. And there's really only one step here, and that's C10. So we might go ahead and just solder C10 on there for you if we have enough extras. But who knows what the future holds. I'm not in the future right now. You are, and so you know what happened. But I suppose it's worked out really well for you. And if I could, I'd tell you the lottery numbers of the future, and you could give me a little bit of that, and life would be pretty different from that, I guess. But I like it. It's fine. Life is good. There we go. I'm back to babbling. All right. There we go. Oh, man. I've kind of choked here at the end on these little guys. You're all probably skipping this anyway because you're so much better. You're like, what is this problem? Okay, I'm holding it. I'm going in. There we go. My tip actually feels like it's not getting hot, and maybe I need to make sure I've got a good bit. Oh, look at that. I've got some de-shining happening with my sensor here, so my solder iron. I might have to pull out that old tinning block again. You really want to see the solder flow along that tip, and if it's not, then something has happened. It's really important to keep a shiny tip, and that's a little bit better without having to tin it. It's terrible that you can't see all this when I'm trying to do it, but there, that's better. A little bit of cold solder on that side, so I'm going to go ahead and, oh, look at that, that's beautiful. It's sticking right up in the air. Okay, let's go to this side.